Welcome to another video lesson for Integrated Math 2. Today we're going to be looking at reviewing graphing lines and how we can use graphing lines as an alternative to solving algebraic equations. Let's go ahead and get started. To begin with, let's go ahead and review finding the slope and the y-intercept given a graph. To identify the slope of our line, we're going to read our line going from left to right, and we can see that our slope is definitely increasing. So this line would have a positive slope. To identify our slope, we're going to find 2 points that are on our actual line, and we're going to count the rise over run. So I would go up 2 and to the right 4. So my slope would then be 2 over 4 for my rise over run, which we can simplify to be 1/2. For my y-intercept, I'm always trying to identify the point where my graph crosses over the y-axis. In this case, it would be right here at the point 0, 2. So I'm going to make that a little bit larger. So we can see that our y-intercept here is going to be the point 0, 2. For our next example here, we can see that our graph is actually decreasing as we go from left to right. It's definitely going down. So we're going to have a negative slope. To do that, again, we're going to identify 2 points that are on our actual graph here. And then I'm going to try and find my rise over my run. So I'm going to be going down. And since I'm going down, that's going to be a negative value. So we're going to go down 3. And then we're going to go to the right 2. So that's going to give me a slope of negative 3 over 2. And we can't simplify that, so that's going to go ahead and be our slope. Again, for our y-intercept, we're trying to identify where our graph crosses over the y-axis. And so as we trace through with our graph, we can see that it crosses over right here at 0, negative 5. So that means that our y-intercept is going to be the point 0, negative 5. All right, once again, we're going to go ahead and identify the slope and the y-intercept. We can see that our line is a decreasing line as we go from left to right. It's definitely going down again. So we're going to go ahead and identify 2 points on a graph here. And we're going to identify our rise over our run using these 2 points. So I'm going to be going down. Again, since they're going down, that's going to be a negative value. And then we're going to go to the right 1. So for my slope, we're going to have negative 3 over 1. If instead I wanted to go over and down, so I could go to the right 1 and then down 3, I would still have the same value. I'd still have a negative 3 over 1 because my rise would be negative 3 and my run would still be a positive 1. So it doesn't matter if we go down and over or over and then down, we're going to end up with the same slope. For our y-intercept, again, we're going to identify where our graph crosses the y-axis. So tracing my line, I can see it's going to cross my y-axis right here. So I'm going to go ahead and label that point. And that is the point 0, negative 4. So our y-intercept is going to be the point 0, negative 4. All right, why don't you guys go ahead and attempt this one on your own. So identify the slope and the y-intercept, and then come back and check and see if you got your answer right. So hit pause now, and then come back and see if you got it. All right, so we can see that we're going to have a positive slope again. Our line is definitely increasing as we go from left to right. It's going up. Using our 2 points, we can see that our rise is going to be up 2, and our run is going to be over 3. So we have a slope of 2 over 3. And then we can see that our graph crosses the y-axis at 0, negative 2, which gives us a y-intercept of, again, 0, negative 2. One of the most common forms of linear function is slope-intercept form. And in this equation, we have 2 variables that we use to help us assist when graphing. Our equation is the following: y is equal to mx plus b, where m and b are the variables that we use when we're graphing. Now, when I graph this, I'd like to identify my y-intercept. So b is going to help me identify my y-intercept. 0, comma b is always our y-intercept. And I use that as my starting point. So I'm going to start by graphing the point 0, comma b. Once I've done that, I'm then going to identify my slope. And I want to use m as my slope. And I like to use a fraction here to find my rise over my run, to then tell me how to go from my y-intercept to my next point on my graph. Now, in the case that our slope is an integer value or not a fraction, you can put it over 1 to make it a fraction, which we'll see happen in one of our examples. Let's go ahead and apply this to review graphing some equations. Looking at our equation here, we have f of x is equal to 2x minus 4. We'd like to go ahead and identify b, so we can use that to find our y-intercept, and then identify our slope, so we can use that to find our rise over our run. Our b value is going to be the value that is by itself, so it's not attached to the x, which means this negative 4 is going to be your b. To turn it into our y-intercept, we have a 0 in front of that, so we have 0, comma b, which means in this case, we have 0, comma negative 4. I'm going to go ahead and graph that. Then we can identify our slope, which is our other number, in this case, the 2. And when we're graphing, we really would like for that to be a fraction. So it's not a fraction. I'm going to go ahead and put it over 1. And now I know what my rise and my run is to go to my next point. So from my initial point, again, our y-intercept is 0, -4. I'm going to use my slope to go up 2 and then to the right 1 to get to my next point. So again, we're going to go up 2 and to the right 1, up 2 over 1. And I'm going to do that one more time to get a third point. That way, when I go to draw my line, I've got that third point to kind of balance it out. And there is my linear function. Example 4 here, our equation is f of x is equal to -5 over 2 times x, and that's it. Since we don't have a value there for b, I'm going to do plus 0 to kind of help represent what b should be, which means if my b value is 0, then my y-intercept is going to be the point 0, 0. Looking at my equation, my slope, again, is that number I'm multiplying by x, which in this case is going to be -5 over 2. And we have two options here. The negative could go with a 5 or the 2. It doesn't really matter. We're going to end up getting the same slope regardless if it's -5 over 2 or 5 over -2. But I went ahead and put it on top. To graph this, I'm going to go ahead and start with my y-intercept. Again, that is 0, 0. And then for my slope, because I have a -5 over 2, I'm going to go down 5 and then to the right 2. So from 0, 0, we're going to go down 5 and then to the right 2. And then I'm going to do that one more time. All right, now I mentioned that we could have taken the negative sign and switched it. So I could have said that my slope was 5 over -2, which would tell me to go up 5 and then to the left 2. So let's do that from 0, 0. And we see that point would still fall in line with our other points. And when I connect them all, I have my straight line. Okay, your turn. Go ahead and identify the slope and the y-intercept and use those to help graph this linear function, and then check back in and see how you did. So hit pause now. All right, for our example, we can see that our b value is 1. Turning it into our y-intercept, we again have a 0, 1, and I went ahead and graphed that point. Then for our slope, our n value is 1/2. Since it's already reduced, looking at them, I have +1 and +2. I'm going to go up 1 and then to the right 2. So we can see from my point 0, 1, I went up 1 and to the right 2, and then up 1 and to the right 2 again to make sure that my line is balanced, and then we graphed our line. For our next example here, we have f of x is equal to 7, and I'm going to go ahead and rewrite this a little bit. We don't technically have an x value, so I'm going to say this is the same as 0 times x plus 7. And rewriting it in that way might help us identify m and b a little easier. So b, once again, is going to be my number that's not attached to the x. It's going to be the 7, which means that I have a y-intercept of 0, 7. And then for my slope, again, technically it's a 0 times 7, so my slope is equal to 0. If I go ahead and use this to graph, I have a point 0, 7. And then having a slope of 0 just means I have a horizontal line. So when I go to graph this, again, I have a horizontal line that's representing my slope of 0. And for our last example here, we have x is equal to -4. Now, unlike the last example, this one does not have a y value, so we actually have no y-intercept. And since I have simply an x, I know that x is going to equal a -4. And it's going to equal -4 no matter what y is. So in this case, I had y being 0. I also have the point -4, 2. I could have the point -4, -5. But essentially, x is always going to equal -4 regardless of what y equals. So we have a vertical line here. And when we talk about our slope here, we can say there is no slope, or a better way to say it is it's undefined. For our next example, we're going to go ahead and solve this system of equations algebraically, and then we're going to use our graph to verify that our algebra was in fact correct. So one thing that I noticed is they both equal f of x, both of my equations, which means I can do substitution here, and I can say instead of f of x equals 3x plus 5, that 2 is equal to 3x plus 5. Then we'd go ahead and go through the process here of getting x by itself. So we're going to subtract 5 first. And we get -3 is equal to 3x. And then if I divide by 3, then we get -1 is equal to x. Knowing that -1 is equal to x, I can now go ahead and plug that into my equation. And if I evaluate f of -1, we get 3 times -1 plus 5, which is going to be -3 plus 5, or positive 2. So I have the answer of the point -1, 2. All right, that's the algebra approach. Let's go ahead and try and graph this. If I want to graph 3x plus 5, I'm going to go ahead and start at a y-intercept of 5. And then my slope is 3, so I'm going to go up 3 and to the right 1. And then I'm going to do the opposite. I'm going to go down 3 and to the left 1. And I have enough points to go ahead and draw my line here. All right, then if I go ahead and I graph my second equation of f of x is equal to 2, I'm going to have a horizontal line that goes through y equaling 2. And we can see that we do have a point of intersection. And that is the point -1, 2, which was what our algebra told us as well. So you can see here that by graphing the lines and finding the point of intersection, we got the same answer that we found by doing the algebra. For our last example, we're going to go ahead and evaluate f of -3 algebraically, and then we're going to do it graphically as well. Algebraically, we're going to go ahead and plug in a -3 for our x. So we have f of -3 is equal to 2/3 times -3 minus 1. When I simplify 2/3 times -3, the 3's will cancel and you just get a -1. So I now have -2 minus 1, which is equal to -3, which means that I have the point -3, -3. If I plug in -3, my input, then my output is also going to be -3. Let's go ahead and take a look at how we can do this graphically as well. I'm going to start by graphing my equation, 2/3 x minus 1. I'm going to start with my y-intercept of -1. And then since my slope is 2/3, I'm going to go up 2 and over 3. I'll do that one more time. And now I'm going to go ahead and graph my line. And now what I'm going to do is trace my line and try and figure out the corresponding y value for an x value of -3. So if I go over to -3 and I go down, I can see my y value is also going to be -3. So essentially we have the exact same point of -3 and -3. All right, that does it for the notes for this lesson. Go ahead and get started on the homework, and good luck.